Write down this on your notes. You minus 5x plus 6, okay? Yeah, you want to change this guy to somebody plus somebody, okay? You want to change your denominator to two parts, okay? One is a over x minus 2, one is b over x minus 3, okay? Let's do this question together. Watch out over here, okay? Look.
Okay.
Yeah, partial fraction. Okay, this is the most important foundation for next year calculus BC. When we want to do those integration, we have to do those partial fraction first before we can do the integration. So how do we get the a and b value? We can know that this guy equals to x minus 2 times x minus 3, and then ax minus 3a plus bx minus 2b, right? That makes sense?
I think, yeah.
So a plus b times x minus 3a minus 2b, and then over x minus 2 times x minus 3. Correct?
Yeah.
Then we will have this system linear equation, which is a plus b. Look at this. That's equals to 1. Look at this. This equals to 0. So 3a plus 2b equals to 0. That makes sense?
Yeah.
I don't understand why your school want to teach the partial fraction so early. They didn't teach this part, right? They just gave you this homework.
They gave us the homework and they gave us little videos, kind of, and they said, good luck, have fun.
Oh my gosh. This is crazy.
Yeah, I'm surprised that they put these topics in the asynchronous days instead of like actually bothering to teach it.
This is a very hard topic. Okay, so we times the first equation by 3, so becomes to this. Then b is going to equals to 3. Okay, yes, we times this guy by 3. We use this guy minus this guy canceled. 3b minus 2b is 1b, so b is 3. If b is 3, a equals to negative 2. All right?
Right. Okay.
That makes sense? Okay. So this is a general way. This is a common way to solve this equation, to solve this partial fraction. Now I'm going to teach both of you a very quick way of doing this question. Okay. So there is another way to do this one, but to do that one well, we have to make clear about this thing. So I'm going to use x minus 2 to times each term, okay? So the left side becomes to x minus 2 times each term, x minus 2 will be canceled. So this is x minus 3. This becomes to a. This becomes to b times x minus 3, and then times x minus 2. That makes sense?
Yeah,
yes.
That makes sense.
And then I'm going to let x equals to 2. If I let x equals 2, the left side is 2 over 2 minus 3, which is negative 1, equals to a. Plus x minus 2 is 0, so this term is 0 for sure. Yes? That's why a equals to negative 2. Okay? This question is easy to solve the system linear equation. Sometimes it's very complicated one. It has like 4 variables. And we will use this way to do those calculations quick. Okay, very quickly. Same answer, right?
Yeah.
Okay. Now, previously I used x minus 2 to times each term. Now I'm going to use x minus 3 to times each term. Then x minus 3 times each term, the left becomes x minus 2. Here is a times x minus 2 times x minus 3, and then plus b. Now I'm going to let x equals to 3. If x equals to 3, the left one is 3 over 1. And this guy is 0. So b equals to 3. All right. Does that make sense?
Yeah.
Okay. So this is called a partial fraction. Now we go to the worksheet from your school. Let's look for the similar one. Okay. It's so strange. Your school comes to all hard type. Yeah, this one is the same one. Let's do this question first. All right. Here, what's the denominator?
Wait, for which one? 8 or 9?
Number 9.
Number 9?
Oh, number 9, we have to do the long division first.
Oh, can't
Number
you?
9, we have to do the long division first. If the top one is higher than the bottom one, we have to do the long division first. Okay.
Oh, okay.
Yeah, because wow, your school gave so hard question to students.
Maybe they just like seeing us suffer.
The order is so strange. Partial fraction is the last topic for pre-cal. I don't
Really?
know. Yeah.
Why are we doing it right now?
Usually it is like the second semester in May.
Oh my god, what? Wait, that actually makes no sense.
For Clemens, they teach this part second semester in May. Hold on. 2x times this guy is 2x cubed times this guy is 6x squared. Okay. Then plus 4x. I think somehow a teacher put the wrong thing because suppose you should learn the optimization right now. Same, you get this result, right?
Yeah, wait, this stuff is actually so difficult. Oh my god, I'm looking at the notes pages and this is...
Yeah, it's okay, it's okay. I will guide you through there. Don't worry, okay? Yeah, we will be there. Minus 7. And here is negative 7x squared. You can also send me your school notes, okay?
Okay.
Yeah, that part is not so easy to self-learn. And then here becomes to 18x, then plus 19, right?
Right.
So that equals to x. I'm going to make this guy smaller. So this guy equals to x squared plus 3x plus 2 plus 18x plus 19, and then over x squared plus 3x plus 2. And then we do the second part. For the second part, this will equals to, we are not going to worry about this part, okay? We only take the second part. 18x plus 19 over x plus 1 times x plus 2 equals. So we do ax, like here. We do a plus b on the top.
Okay, wait, when do you use bx plus c and when do you just use b?
Oh, bx plus c is in some other scenario. So there are many different scenarios, okay? We do, when the denominator has this kind of thing, we do bx plus c, okay? When your denominator has a factor as this kind of shape, you do bx plus c.
So is it like when the power of x and the denominator is greater than 1, you use bx plus c?
Right, yes.
Oh, okay, that makes
Yeah.
much more sense.
Yes, good summary.
Okay.
When your denominator is bigger than 1, you do bx plus c, okay?
Jeez,
Yeah.
okay.
Not yet, not yet. I remember last year, Clemens teacher didn't teach this part either. They just gave the students the notes and a worksheet, and next day it's a test. Like most students fail. So we times x plus 2 for each side, all right? Yeah, I don't want to list the system equation. I'm just doing, I times x plus 2 for each side. Okay. Then x plus 2. Here is plus b, you know, and I let x equals -2. Then b equals to -36 plus 19 over -1. This is a positive 17, right?
Right.
Okay. And when x equals to, so we solve the b first, and then we times x plus 1. So this guy divided by x plus 2 equals to a plus b times b divided by x plus 2 times x plus 1. And I'm going to let x equals to -1. And then a equals to -18 plus 19 over 1. So that's equals to 1, okay? Yes. So by this way, we can write down our equation, our function as 1 over x plus 1 plus 17 over x plus 2. All right? Yes. Okay.
Yeah, okay.
Okay. And look at your example. This is only one example corresponding to the first type. Okay. All the other things we have to use the bx plus c. Now, that's the first step. Now we look at the second example. The second example is this. Yeah, we are going to do this way, okay? This is a type 2. Maybe your physics C needs those kind of integration skills. That's why your pre-cal teacher teaches this in advance, really?
I don't think anyone in I don't think we can take physics C without having calculus background though.
Right, that's
Because
true.
yeah, they won't let you take it. I think Jaden tried.
Really?
Yeah, he was talking to someone and they asked him why he didn't take physics C and he's like, I haven't learned calculus yet, so I couldn't. So I think he was going to, but I don't know.
Yeah, physics C is going to ask you doing this integration, okay? Yeah, so without pre-cal, you don't know this. And without this, you won't be able to do the integration, okay?
Okay.
Now let's do this type. Your school is really crazy.
Yeah. Oh, so this one requires bx plus c, so it's a
Yeah.
over x
Mhm.
minus 1 plus bx
Yeah,
plus
so
c. Okay, right.
because you have this guy is second order. This guy is x minus 1. For first order, your numerator is just a constant. For second order, your numerator is bx plus c, okay? Yes. Same thing, okay? I'm going to use this guy. I'm going to first use this guy to times each term, okay? Yeah, this is faster than doing the Sisley equation. I use x minus 1 to time each term. When x equals to 1, the left is 3 minus 5, which is negative 2, over 3 equals to a. Okay? So a equals to negative 2 over 3. Does that make sense?
Yeah, that makes sense.
Okay. Now, we want to solve the bx plus c. Bx plus c. The problem is we have to, first step, we let x equals to 1. That's an easy one. And then we have to do those multiplications, okay? So I'm going to plug in negative 2 over 3 into here. Now a is replaced by negative 2 over 3. Okay. Now I'm going to times x squared plus x plus 1 for each term, okay? So this guy was times for each term. This guy canceled. This guy was timed to this, so I put them individually, okay? Here is this. This second term is this. This third term is this, right? And this one was gone. So that is bx squared minus bx plus cx, and then minus c, right?
Yeah.
Now, we are going to make each different order, okay? This guy with this guy, that means negative 2 over 3 plus b equals to 0, right?
Right.
Okay, so we take care this term. Now, for the x term, 3x equals negative 2 over 3x, and then minus bx plus cx, right?
Yeah.
Now, this is a purple term. All right, this is a purple term. Last one is a constant term. Negative 5 equals to negative 2 over 3 minus c. Yes? So that is y equals to 2 over 3 plus c. So c equals to 5 minus 2 over 3, right? Okay. That's right.
Yeah.
Now we plug in x are all gone. So 3 equals negative 2 over 3 minus b plus 13 over 3. All right. 3 equals to 11 over 3 minus b. So b is equals to, which is 2 over 3. All right. That's it. Make sense?
Yeah.
Yeah, that's the ABC value. Okay. Yeah. So when we have this kind of denominator, the numerator is going to be have a bx plus c. Okay.
Okay, this is so.
Now, now we can go to your paper. Let's see. But this one really, do they ask us to do the imaginary? This looks like they ask us to do the imaginary one.
I think so. I don't really know, if I'm being honest, what they want, but
The thing your school asks is so strange. Does your teacher's notes including imaginary one?
I think so.
Your school also have the imaginary one, right?
Yeah, I think so.
Your school
Or
is crazy.
I don't know. They have non-imaginary factors, but usually it's like x times x squared plus 10. In the notes page, at least. I think this one also, yeah. This should be the same thing. Holy crap.
Hold on. Let me see on my notes first. So we have the type 2. Type 2. This is a type 2. Okay. This is a second type. That's what we did. This is second type. And next one is this kind of thing. Yeah, it's this kind of thing, which is also possible. I don't understand why your school gave that kind of crazy questions. I don't have those kind of things. Let's see here. Yeah, even this. Even this. Seriously? I think this is already this one is already the last format. We don't need to continue working on this because for doing this guy integration, there are formula we can apply already. So we don't need to make further actions for this type of question.
Okay.
Yeah, I don't think you need to do this one. This is already.
Yeah, they just wrote 3 over x squared plus 1 as the answer key.
That's it, right?
Yeah, that's it. That's all they wrote.
Yeah, that's it. This is a result already. Okay, and for this one, we do a over x plus bx plus c over x squared plus 1, right? Yes.
Yes.
This is similar with our second type. This is similar with our second type already. This is what we did just now, okay? Yeah.
Right.
We
Okay.
can go ahead to this one. We times x for each term. We times x for each term. And then we let x equals to 0, okay?
Okay.
When x equals 0, this is 1 over 1 equals to a. So a equals to 1, right?
Right. Right.
Now a equals to 1. Then we times x squared plus 1 for each term, okay?
Okay.
So x plus 1 equals to a is 1 times x squared plus 1. X squared plus 1 was times, so this guy is canceled. So that becomes to bx squared plus cx. Okay?
Okay.
Yes.
Yes.
So b equals to negative 1. Okay? B equals to negative 1. And c equals to 1, right?
Right.
B equals to negative 1 because 1 plus b is 0. And then c equals to negative 1 and 1 equals to 1. Right?
Right.
So that guy is a is 1 plus negative x plus 1 over x squared plus 1. Okay? That's it.
Yeah.
Now this is 2. Okay. Yeah. This guy is already, that's already the formula. We don't need to further do anything. Now let's do the number 3. Yeah, actually I want to put 8 in front. Okay. X plus 3 and then a, then plus b, x plus c over x squared plus 9. Right?
Yeah.
Now I'm going to, actually 18 and 18 can be gone, okay? So that means 1 over okay. Now I'm going to times x plus 3 for each term, okay? Now x equals to negative 3. X equals to negative 3. This guy is 1 over 18 equals to a. Correct?
Yeah.
A equals to 1 over 18. Now I understand why they put 18. Okay. Now bx plus c. Oh, so we are going to times x squared plus 9 for each term. Left side times x squared plus 9 is 1. Right side is 1 over 18 times x squared plus 9 plus, so this is bx plus c times x plus 3, right?
Yeah.
I'm equal 18 x squared plus 1 over 2 plus bx squared plus 3b plus cx plus 3c. Yes.
Yeah.
Now, b is going to equals to negative 1 over 18. Okay.
Yeah.
Here, cancelled. And c, 3c equals to 1. So c equal, oh no, hold on. 3c plus 1/2 equals to 1. C is 1 over 6, correct?
Right.
Yeah, we can verify this. We can check if this guy is 0 or not. So if we check 3b, 3 times negative over 18 plus c, that's 0, okay? So we double check, that's okay. So the answer is that guy equals to A is 1 over 18. B is negative 1 over 18. C is 1 over 6. So this is 1 over 18 times 1 over 18 is 1. B is negative 1. C is positive 3. Makes sense to you?
Yeah.
All right. Now we finish this already. Let's see. Okay. Let me compare, okay? Let me compare this shape. This is previously this is to the order of 1. This is to the order of 2. Okay. Now we might have to take a look. Let's check the other type. This is order to the order of 1. I think we can do the same way. Let's take a look at this number 4. Okay. This guy, if I do the same way, so x minus 2, if I do a, then plus bx plus c, okay? And then here is x squared plus 1. Well, that's still possible, right? Yes.
Yeah, I think yeah, this is
Yeah, let's check. Let's take a look. So I make this guy as this shape. And then I'm going to times x minus 2 for each side. right?
Yeah.
And if x equals to 2, now the left side is -7 times 4 minus 8 minus 14 over 5 equals to a, correct? X minus 2 is 0, so this is a. So a is going to equals to -10, right? Yes.
Yes. Yes.
Now this guy equals -10. And then we do -7x squared minus 4x minus 14 equals to -10 times x squared plus 1. Then plus, okay, this guy times x squared plus 1, this guy is gone. We have here. This guy times x squared plus 1 is here, a -10 plug into a. This term times x squared plus 1, denominator is gone. We are going to take care of this top one. Correct?
Right.
Okay, now -7x squared minus 4x minus 14 equals -10x squared minus 10 plus bx squared plus c minus 2b parenthesis x, right?
Yeah.
Minus 2c. So we take care this second order term. -7 equals to -10 plus b. So b equals to +3. Okay. -4 equals to c minus 2b. -4 equals to c minus 6. B is 3, so 2b is 6. So c equals to 2. Now, just want to verify that our calculation is correct. Constant term on left is -14. Constant term on the right is -10 minus 2 times 2. That's correct. And then we can say yay, okay? Now, that means the result is we can change our A value, B value, and C value, okay? A is -10. B is 3. C is 2. Does that make sense?
Yeah.
Yeah. Not so hard now, right? Yeah, feel better? Let's do 5. For 5, we still do this thing. The only difference is we can change this guy to A over X. Okay. Now, if I times x for each term, when x equals to 0, your left one is -1/1 equals to a. So a equals to -1, right?
Right.
And then we plug in. We are going to times this guy to each term, okay? This guy, the denominator times this guy times this guy times this guy. So your left becomes to x squared minus 1 equals to a is -1 times x squared plus 1 plus this guy was taken away. That is bx plus c times x. This is x squared minus 1 equals negative square x minus 1 plus bx squared plus cx. Okay, so x squared equals to negative x squared plus bx squared. That means b equals to 2, right? Yes.
Yes.
-1 is gone. So this term is take care. -1 was gone. That means c can only be 0. All right.
Yeah.
So the final result is a is -1. A is -1. B is 2. C is 0. That's it. Right?
Right.
Okay. That's it. Not so complicated now. It's okay. Yeah. In calculus, when you have this guy, previously, if you want to do the integral of this guy, impossible. Now, when you want to do this guy, this equals to negative ln x absolute value, and then plus something like arctangent something. Okay. Yeah, we will be able to
Okay.
do this next year. Now, last one. You don't look at my answer. Solve this by yourself. Yeah, both of you solve this guy by yourself. All right.
Okay.
Yeah, both of
Wait,
you do this by yourself.
Is it possible if like A or C is like 0? I mean, A or B is 0?
And if this guy is not 0, A and B couldn't be 0. C is 0. C could be 0. Okay. Yeah. You don't know, you don't expect A or B or C equals to how much until you use this way to solve your A and B first. Okay. That makes sense?
Yeah, that makes sense.
Yeah. Now go ahead and solve this by yourself. But you want to be careful. Okay. You want to list A over x minus 2, plus bx plus c over x squared plus 4. Does that make sense?
Yeah, this makes sense.
You cannot put ax plus c over here. That's wrong. Okay. Yes. Look, only this guy square has the x. This guy to the power 1 is a. It's a constant. Okay. Go ahead. You can enjoy this question. Regular pre-calculus will not teach this partial fraction at all. Did you get it? The same answer.
Hang on, give me a second.
Can you explain how you got B again?
B?
Yeah.
Do you have this same step?
Yeah.
X squared, there's no other x squared. So this guy plus this guy has to equal to 0, okay? Yeah, this is the first order. This is first order. Let the first order equal. Let the constant term equal. Let the second order equal. Okay. So 5/4 plus b equals 0. So b equals negative 5/4. Yes.
Right.
Yeah.
Yeah. Because this is the equation which is always true. Doesn't matter x equals to what value. So if your second term, you put your second term together, should equals to 0. Okay. Yeah. Your left side does not have x squared term. Your right side has x squared term. So you have to make this guy plus this guy equal 0. X squared coefficient equals 0. So this guy is negative 4, 5/4. Make sense?
Yes.
Angela, makes sense?
Yeah.
When you get a B, then you get a C. C is looking for this first order. This guy first order is C minus 2B. This guy first order is 4. So 4 equals to C minus 2B. Okay? Yes.
Okay.
And then C plus C minus 2B is C plus 5/2. 5/4 times 2, which is 5/2. Minus times minus is plus. So you get C equals to 4 minus 5/2, which is 3/2. But when you come to here, don't think everything is done. You want to double check. You want to check your constant term. Your left side constant term is 2. Your right side constant term is 5 minus 2c. 5 minus 2c. So this is 5 minus 2c minus 2 times c. c is 3/2. And you want to verify if this is true. 2 equals to 5 minus 3. True. Yay. That's the answer. Okay. You do see that each time I check it, right? Yes.
Right.
Each time I check it, you have to check it. Otherwise, if you do something mess up over here, you didn't calculate correctly, you lose all your work. You lose all your work. Next year, calculus BC, they are going to ask you do the integration of this one. So this is the first step before you can do in the integration. If this guy is gone, is wrong. Everything else is wrong from here. Okay? Make sense?
Yeah.
Okay. Now we can do number 8 also. Let's try number 8. Yeah, you can try by yourself, okay? You always put a over x plus 1 as a first, and then bx plus c as a second, because this guy denominator is to the second order. Times x plus 1 for each term. I have a typo over here. Check the question. Okay, I finished number 8 and number 7.
Wait, how did you get b is equal to 1/2 number 8 again? I think I messed up there somewhere.
A equals 1/2
Yeah.
because I make x equals to -1. Okay. Look,
Oh,
I
okay,
times
okay.
x plus 1 for each term. Yes, I plus x plus 1. I times x plus 1, so this guy is gone. This is left. Then x plus 1 times here is gone, so a is left. Then x plus 1 was here. When I apply x equals -1, this is 0. This thing can be ignored. This guy is -1. -1 squared is +1. -1 squared is +1. So this is 1/2. That's why a equals to 1/2.
No, I meant like b. How did you get b as 1/2? I mean,
B,
yeah.
when I times x squared plus 1 for each term, x squared plus 1 times here, x squared is left. This guy is gone. A times x squared plus 1. I already have a equals 1/2. And then x squared.
Oh, okay, okay. Wait, yeah, I got it
And
now. I
then
got
x squared plus 1 was gone. So bx plus c times x plus 1. Okay. Yeah, you do a lot of work right now. Next year, when you do the calculus integration, this thing for other people, there's no way they can do this. Okay. If they didn't do this well, there's no way they can do the partial fraction for the integration calculation. Does that make sense?
Yes.
I don't have enough time to teach the last question, but I show my work here. When you have somebody, okay, x squared plus 2 to the power 2, that's the other type. You do ax plus b over x squared plus 2, and then plus cx plus d, then over x squared plus 2 parentheses square, okay?
Okay.
And then you times this whole big thing to each term, and then list them, okay? Let each part corresponding equal. All right?
Oh, geez. Yeah, okay.
Yeah, I'm going to upload the notes, okay? Yeah, you can tell. It's not so that hard, but if you never see this before, first time you might feel this is overwhelming. All right. That's a partial fraction. And okay, I give you 2 worksheets, okay, with all my notes and explanation.
Okay.
All right, yeah, that's hard work. Good. Yeah, see you next week, okay?
Okay.